Okay, guys, so the final problem for this chapter, or at least the final type of problem for this chapter, 6G, is all about elastic collisions. And we studied inelastic collisions, and they tell you they're inelastic because they stick together, and so the final has to be the combined mass times the final velocities. They both move away together. But when we look at elastic, it's completely different. Think of elastic more so like your pool table. When you hit one ball, the other ball usually ricochets, and your original ball usually changes direction and changes speed. And so we're going to get a different type of conservation of momentum. And it's actually a little bit simpler in my opinion. And so let's work through it. An American juggler, Bruce, we're going to call him Bruce, juggled 11 identical balls at one time in 1992. Each ball had a mass of 0.20 kilograms. Suppose two balls have an elastic head-on collision during the act. The first ball moves away from the collision with the velocity of 3 to the right, and the second ball moves away with the velocity of 4 to the left. If the first ball's velocity before the collision is 4 to the left, what is the velocity of the second ball before the collision? And so we start with what we know. We know that the mass of all the balls is 0.20 kilograms. We know that the initial velocity of ball 1 is, 4 to the left, so that makes it negative. And the final velocity of ball 1, 3 to the right, making it positive. Initial velocity of ball 2 is what we're looking for, and the final velocity of ball 2 is negative 4. So we do our equation. Mass of the first one, initial of the first one, mass of the second, initial of the second, has to equal mass of the first, final of the first, plus mass of the second, final of the second. Well, we know that all the masses are 2. So 2 times negative 4 plus 0.2 times what we're looking for equals 0.2 times 3 plus 0.2 times negative 4. I hope you guys see the pattern here. You definitely could have eliminated all the calculations by eliminating the mass, but let's say that you don't pick up on that because you're stressed and you're tired and it's the last period of the day, or it's the middle of the day and you guys just want to go to lunch, whichever class you're in. So I'm going to do all the calculations out. Oh, this is minus 0.8, and I get 0.2 V2 equals 0.6 minus 0.8, which is negative 0.2 plus 0.8, which is what I bring on over, equals 0.6, and I get that V2 is 3, and it's positive, so it's moving to the right with a velocity of 3. That's it for this chapter, guys. Practice. I'll see you guys Monday. Have a good weekend.